Welcome to CE 405 Environmental Engineering 1 Module 3 Part 5. In the previous sessions, we already discussed about plain sedimentation tanks, its important parts, clarifoculator, that is sedimentation aided with coagulation tanks, and its important parts. In this session, I'm going to discuss about the design of plain sedimentation tanks. How to design a plain sedimentation tank. Design concept in plain sedimentation tank. First, we have to think about the overflow rate, surface overflow rate or surface loading rate. That is the amount of water entering into the system or into the sedimentation time in a sedimentation tank in a preferred time. That is, we are representing this overflow rate as VO. That is actually Q divided by BL. Q is the amount of water entering into the sedimentation tank divided by cross-sectional area of the tank. That is breadth into length. That is B into L. We have two types of settling, that is type 1 settling and type 2 settling. Type 1 settling, we already know the Stokes law and its derivations and its peculiarities. The second type is the sedimentation aided with the coagulation. In both type 1 and type 2 settling, we are adopting different overflow rates. In designing a plain sedimentation tank, we have to consider the overflow rate in the range of 12 to 18 meter cube per day per meter square cross-sectional area of the tank. That is 500 to 750 liters per hour per meter square cross-sectional area of the tank. In the type 2 settling, we are accepting 24 to 30 meter cube per day per meter square cross-sectional area of the tank. That is 1000 to 1250 liters per hour per meter square of the cross-sectional area of the tank. While designing a plain sedimentation tank, we have to adopt a value in between these two, that is in between 12 and 18 in terms of meter cube per day per meter square. And in the case of liters per hour per meter square, we have to consider a value between 500 to 750. Likewise in the type 2 settling also. This is the first factor we are going to accept or assume while designing a plain sedimentation tank. The second one is the depth of the tank. That is basically it is between 1.8 to 6 meter. That is the depth of the tank. Usually we are considering it in between 3 to 4.5 meter because it is apt for a medium-sized or acting for a medium-sized population water treatment system. For a tank without mechanical scraper, that is for a manual removing of the sediments, we should give additional depth for storage of sludge called sludge zone. That is in accordance with the sediment deposition in the sedimentation tank, we have to consider the sludge zone. That is, except this depth that is 1.8 to 6 meter, we have to provide an extra depth of 1.2, that is 0.8 to 1.2 meter. Then provide a freeboard of 0.5 meter to avoid overflow. That is, in the case of maximum flow, there will be flow up to the total depth of the tank. Then we have to avoid this. We have to provide a freeboard. So in addition to this depth, that is 1.8 to 6 meter, we have to add 0.8 to 1.2 meter additional depth for sludge zone in the case of manual removal of sludge from the sedimentation tank, and we have to provide a freeboard of 0.5 meter to avoid the overflow. Then the third term is the detention time. Detention time, as you know, what is a detention time? And we have to calculate this detention time. That is volume or capacity of tank divided by rate of flow of discharge is known as the detention time. That is, we can write the equation as breadth into length into height or depth. Q, that is the discharge or rate for rectangular tank. In the case of a circular tank, the equation will be d square into 0.011 d plus 0.785 h divided by q for a circular tank. Then by assuming the detention time, we can take the values as 4 to 8 hours for type 1 settling and 2 to 4 hours for type 2 settling. In the first type 1 settling, the sedimentation is happening in the sedimentation tank itself, and in the case of type 2 settling, the sedimentation is happening, flocculation is happening. After flocculation, the sedimentation is happening. That's why the detention time is lesser compared to type 1 settling. In type 2 settling, the detention time is 2 to 4 hours, and in type 1 settling, it is 4 to 8 hours. Then the width of the tank. The width of the tank should be less than 12 meter, and the length of the tank will be 1 to 6 times that of width. The horizontal flow velocity. The flow velocity, that is the, we have to control the flow velocity in order to enhance the settling action of the sediments. So we have to consider as an important factor that horizontal velocity, we have to control it also. Then flow velocity will be 0.15 to 0.9 meter per minute. Usually we are accepting the value as 0.3 meter per minute. Then the total amount of water flow from tank for 24 hours should be equal to the maximum daily demand. Whatever be the maximum daily demand, that will be the total amount of water flow from the tank for 24 hours. Then next is check against the score. Scoring will happen in the sedimentation tank, and we have to check the scoring velocity in order to avoid the scoring action in the sedimentation tank. Then the scoring velocity, that is our velocity of flow should be less than the scoring velocity. Then we can control the scoring action in the sedimentation tank. Then the Vd is equal to root of 8 beta divided by f dash into g minus 1 into d. This is the equation for scoring velocity, and beta is a constant of 0.04, and f dash is Darcy-Weibach friction factor, and 0.025 to 0.3. By calculating the score velocity, and that should be greater than the velocity of flow in the tank, then we can avoid the scoring action in the sedimentation tank. Then next is the inlet arrangement. Inlet arrangement is shown in the figure, and the channel extending full width is provided for entering water. That is, inlet pipe is attached to the feeding channel that will be opened throughout the width of the channel. This entire water is distributed over the width of the channel. This is provided in this way because we have to control the entering of the water, that is the impure water, into the sedimentation tank in a uniform rate and in a controlled manner. Then the outlet arrangement. A channel extending full width is provided for taking water outside. If a rectangular tank is provided for sedimentation purpose, then the outlet will also be extended up to the full width of the tank in order to avoid the entry of the sediments into the outlet channel. And we have to control the flow velocity from the sedimentation tank to the outlet channel in order to avoid the entry of sediments into the outlet channel. In the case of a circular tank, this outlet will be at the periphery of the circular tank, and throughout this periphery, that is the perimeter of the circular cross section, the outlet channel is provided, and through this the clarified water is collected. Then the next operation is cleaning and sludge removal. Manual operations are there. In manual operations, we will stop the water supply and drain off all the contained water till the depth remaining 30 centimeter, and the sludge is stirred and removed as a slurry by using a pipe or a motor system provided at the bottom. Use pickaxes to remove the hard materials. The fully deposited materials will be firm like hard rock, and it should be removed with the use of pickaxes. In the mechanical scrapping system, the sludge is scraped out and brought to the bottom continuously, and this sludge at the bottom is removed by pumping. This is a continuous operation. The sedimentation process is continuously happening, and while happening this process, this sludges are removed from the bottom by pumping. Then short circuiting. What is a short circuiting? Short circuiting means if the sediments entering into the sedimentation tank will not settle in the sedimentation tank and it is entering into the overflow tank. This is because the detention time provided for this water flow or the water body will not be enough to settle down the sediments in the bottom of the tank. Then if the water current permit a portion of water to pass directly through the tank without detained in the intended time, the flow is said to be short circuited. That is, if a water particle entering from one end and it will pass through directly to the outlet, it will not settle down in the sedimentation tank, and it will not detain in the particular mentioned detention period in the sedimentation tank, and it will directly pass on to the outlet channel. Then the process is short circuited. Then all the sediments carried in the water body will be carried out to the overflow channel, and the water purification will not happen. This process is known as short circuiting, and we have to consider this short circuiting also while designing a sedimentation tank. Then the flow through period. Due to short circuiting, actual time will be less than the intended detention time. Actual time is called the flow through period. Then we have to calculate the displacement efficiency, that is flow through period divided by detention time. By calculating this displacement efficiency, we can overcome the process of short circuiting. These are the design factors for a plain sedimentation tank. First is the overflow rate, then we consider the depth of the tank, then the detention time. For detention time, there is two equations, that is for rectangular cross section and for circular cross section. and for type 1 settling and type 2 settling. Then the width of the tank should be less than 12 meter, length of the tank 1 to 6 times that of breadth. Then the horizontal flow velocity, then the maximum daily demand, then check for score, that is the flow velocity should be less than the scoring velocity, then the inlet arrangement, outlet arrangement, then the sludge removal, that is manual or mechanical, then the short circuiting, then flow through period. While designing a plain sedimentation tank, we have to go through all these steps according to the design criteria, or what we are going to design, or if you are asked to design a sedimentation tank's dimensions only, then you have to consider that criteria only. If you have to design the whole plain sedimentation tank, then you have to go through all these steps up to the inlet, outlet, and the cleaning and sludge removal also. Next, we are going to 3 design problems. I am explaining the question here. I will explain this in the next session. And the first question is, the maximum daily demand at a water purification plant has been estimated as 12 million liters per day. Design the dimension of a suitable sedimentation tank fitted with a mechanical sludge removal for the row supplies, assuming a detention period of 6 hours and velocity flow as 20 centimeter per minute. Design the dimension. So we have to design the dimension of a plain sedimentation tank. Here we have given the maximum daily demand, that is the maximum capacity for 24 hours, and the velocity of flow is also given, detention time is also given. Then it is easy to design the dimension that we will explain in the next session. The next question is, 2 million liters of water per day is passing through a sedimentation tank which is 6 meter wide, 15 meter long, and having a water depth of 3 meter. Find the detention time of the tank. What is the average flow velocity through the tank? If 60 ppm is the concentration of suspended solids present in turbid raw water, how much dry solids will be deposited per day in the tank, assuming 70% removal in the basin and the specific gravity of deposit as 2. Compute the overflow rate also. This is a little bit confusing design question that also we will discuss in the next session. And the third question is, design a coagulation sedimentation tank with a continuous flow for a population of 60,000 persons with a daily per capita water allowance of 120 liters. Make suitable assumptions where needed. This is a question for coagulation cum sedimentation tank. This also we will discuss in the next session. Please write these 3 problems in 3 different pages so that we can continue this in the next session. By this, I am stopping here. Take care. Bye-bye. Thank you.